It is just an unordered arrangement of an elements or numbers or symbols or any functions of mathematics is nothing but the matrix. Here for this matrix, 3, 5, 1 by 2 are called as diagonal elements or principal diagonal elements. A vertical line of elements is column, horizontal line of elements is row. So always row into column, so therefore it is 3 into 4. So this is the order of a matrix. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. In this session, we are going to study about the new chapter, Matrices. In this session, we will be looking on what is matrix, what is order of a matrix, and the type of matrices. What do you mean by matrix? A matrix is nothing but an ordered rectangular arrangement of numbers, symbols, or functions. So, for example, let me take a cost of 2 books is 10 rupees. A cost of 5 books will be 50. So, writing the data in terms of a rectangular array is nothing but a matrix. This is usually denoted by the capital letters of English alphabets, and it is written inside the square brackets, that is the big brackets, or the common brackets sometimes. So, it is just an unordered arrangement of an elements or numbers or symbols or any functions of mathematics is nothing but the matrix. So, now a matrices is also used to find the simultaneous solutions of linear equations also, which we will be studying later. We have wide applications of matrices in the form of determinants also, which we will be studying later. Now let's see what is order of a matrix. If a matrix is written in the form, for example, X is equal to A, B, C, D, E, F. So this is a matrix which I have taken as an example. I already said to you it is denoted by the capital letters of English alphabets, and it is written inside the big brackets or a square brackets. So this is here an horizontal lines. They are called as rows of a matrix, and the vertical lines of elements are called as columns of a matrix, and the order of a matrix is written as the number of rows. So for this example, we have 2 rows here. So we'll write 2 rows, cross we'll write, and number of columns. 2 cross 3 is the order of a matrix. I'll take you one more example. Matrix B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So here, how many rows we have? We have 3 rows and 3 columns, cross 3. So 3 cross 3 is the order of a matrix. A matrix A can also have 1 row, 1 column. That is order of this matrix is 1 cross 1. So basically here, we have an example of order of a matrix of the column M cross N, that is M represent number of rows and N represent number of columns. So in general, the matrices of M rows and N column can be written in this form. Matrix A is equal to A11, A12, A1j, A1n, A21, A22, A2j, A2n, and similarly the last row will be M and the last column is represented in N. So A11 represent the element in first row, first column. Similarly A2j represent the element in the second row and jth column. AMN represent the element in mth row and nth column. So thus M represent the row and N represent the column, and I and J will be less than or equal to 1 to M. So here J represents the column and it is always less than N, and I represents the row and it is always less than M. Both belongs to the set of natural number. In general, we write a matrix A in this form. Aij is equal to m cross n, where m represents number of rows and n represents number of columns. So now, note to point that in general, Aij is an element of ith row and jth column. So Ij means ith row and jth column. Just we have to see what is the number of row and number of columns in the given matrix and find out the element in ith row and jth column. Now, the number of elements in a m cross n matrix is always equal to m into n. Suppose the order of a matrix is m cross n, then the number of elements inside the matrix will be equal to the product of number of rows and number of columns, that is equal to mn. So, as if I have taken an example of here, X is 2 cross 3 order. So, 2 3s are 6 elements. 1, 2, 3, 4, 5, 6 elements. We have 1 cross 1, 1 into 1, 1 element. And here 3 cross 3, 3 into 3, 9 element. So, the number of elements can also be determined with the help of number of rows and number of columns. It is just the product of number of rows into number of columns in the matrix. Next, so we have a problem here. In the matrix A, and matrix A contains the element 2, 5, 19, minus 7, 35, minus 2, 5 by 2, 12, root 3, 1, minus 5, 17. Write the order of the matrix, the number of elements, the elements A13, A21, A33, A24, A23. So this is the question they have asked you. So by looking at the matrix here, just we can count the number of rows and number of columns. So here we have 3 rows. So the order of a matrix is 3 cross. Number of columns is 1, 2, 3, 4. A vertical line of elements is column. Horizontal line of elements is row. So always row into column. So therefore it is 3 into 4. So this is the order of a matrix. Next, we need to find out the number of elements. I already said you it is the product of number of rows into number of columns. So 3 4s are 12. So we have 4 elements in each row, that is equal to 12. Next, the element A13. What does A13 represent? The element in first row, third column. So this is the first row and this is the third column. So first row, third column. 1 3 means, so this is A13. So what is the element A13? It is 19. Next we need to see A21. 21 means second row, first column. So this is the second row and this is the first column. So this is the element. Second row, first column element is A21, which is equal to 35. So therefore A21 is 35. Next we have A33, third row, third column. So this is the third row and this is the third column. So A31, A32, A33. So this is third row, third column element. Hence A33 is minus 5. Similarly, we can see A24, second row, fourth column. So this is our A24, second row, fourth column element, which is 12. And similarly, A23, second row, third column. So this is A23. So what is the element A23? That is 5 by 2. So like this, by looking at the number of row and number of column, that is I and J, we can find out the element inside the matrix. Next question, construct 3 cross 2 matrix whose elements are given by Aij is equal to 1 by 2 modulus of I minus 3j. So I and J always represents the row number as well as the column number. Now let's take in general 3 rows, 2 columns. 3 rows means, so we have A11, A12. So 2 columns means we have the elements like this, A11, A12. Next we have second row, first column, second row, second column. Next we have third row, first column, third row, second column. So now the order of a matrix is 3 rows and 2 columns and the elements can be written in this form, that is A11, A12, A21, A22, A33, A31, A32. And now we have a formula, that is Aij is equal to 1 by 2 modulus of I minus 3j. Now let's go on finding the elements here. We have A11. So I is 1, J is 1. So half 1 minus 3. So 1 minus 3. because j is 1, minus 3 is minus 2, modulus of minus 2 is 2, so 2 by 2 will be getting 1. Next we need to find out A12. So half, I is 1, j is 2. So that is minus 3 2s are 6 we have. So modulus of minus 5 is 5. So it is 5 by 2. Next we need to find out A21. A21 is half, I is 2 here and j is 1. So 2 minus 3 is minus 1. Modulus of minus 1 is plus 1 and the value is 1 by 2. Next we need to find out A22. So A22, 1 by 2, modulus I is 2, j is 2. So 2 minus 6 we get, that is 4 by 2, which is equal to 2. Next we have A31, half, 3 minus 3, which is equal to 0. Next A32, half, so 3 minus 6, which is equal to 3 by 2. So now we have all the elements. Let us start filling the elements here. What is A11? 1. A12 is 5 by 2. So it is 1, 5 by 2. Next we need A21, A22. A21 is 1 by 2. A22 is 2. A31 is 0. A32 is 3 by 2. So this is the required matrix. So first write the matrix in general form by looking at by looking at the row number as well as column number. Just replace I and j with the value and find out the matrix. Next question. Construct 2 cross 2 matrix whose elements are given by Aij is equal to I plus j whole square divided by 2. So it's a 2 cross 2 matrix. 2 cross 2 matrix means let me take A is equal to A11, A12, A21, A22. So 2 cross 2 means 2 into 2 implies only 4 elements. So 2 rows and 2 columns. So 2 rows, 2 columns means first row, first column, first row, second column, second row, first column, second row, second column elements. Now let us find out A11. So what is A11? Both are 1 and 1. 1 plus 1 is 2. 2 square is 4, 4 by 2, so it is 2. Next we will find A12. So 1 plus 2, I is 1, j is 2, 3, 3 square is 9, 9 by 2. Next we have A21. A21 is I is 2, j is 1, 2 plus 1 is again 3, 3 square is 9, 9 by 2. Next we will find out A22. Both are 2 here, I is 2, j is 2, so 2 plus 2 is 4, 4 square is 16, so 16 by 2, which is equal to 8. So therefore, what is the required matrix now? Now matrix A is equal to, the elements are 2, 9 by 2, 9 by 2, 8. So 2, 9 by 2, 9 by 2, 8. So this is the required matrix. Next one, so for the same question, construct 2 cross 2 matrix, the second sub question we have. So since it's a 2 cross 2 matrix, the elements of A is written in the form of A11, A12, A21, A22. So clearly we can write A11 is I by j, that is 1 by 1, 1. A12 is 1 by 2. A21 is 2 by 1, which is equal to 2. A22 is 2 by 2, which is equal to 1. So therefore, what is the required matrix now? That is equal to 1, 1 by 2, 2, 1. So this is the required matrix. Next one, construct 3 cross 4 matrix whose elements are given by Aij is equal to 2i minus j. So 3 cross 4 matrix means we have 12 elements. So it is 3 rows and 4 columns. That means we have A11, A12, A13, fourth column is A14. So let us stop here. So since we have 4 columns, the elements in each row contains only 4 elements. Next we have A21, A22, A23, A24. Next A31, A32, A33, A34. So thus we have 3 rows and 4 columns. So let us denote it by capital A. Now let us find out each elements. We have Aij is equal to 2I minus j. So let's take now A11. So 2 into 1, I is 1, j is 1. 2 ones are 2. 2 minus 1 is 1. Next we take A12. So it is 2 minus 2, 0. Next we take A13. So 2 minus 3, which is minus 1. Next we take A14. So A14 is 2 minus 4, which is equal to minus 2. So first row elements is done. Now let's move on to the second row elements, that is A21. So I is 2, j is 1. 2 2s are 4 minus 1, 3. So next A22. So 4 minus 2, 2. Next we have A23. 4 minus 3, 1. Next we have A24. 4 minus 4, 0. Next we will move on to the third row elements, that is A31. A31 means 6 minus 1, 5. A32, 6 minus 2, 4. A33, 6 minus 3, 3. A34, 6 minus 4, 2. So now we have found all the elements of each row and each column. So therefore the required matrix will be matrix A is equal to, so first row elements are 1 0 minus 1 minus 2. 1 0 minus 1 minus 2. Second row elements is 3 2 1 0. 3 2 1 0. And the third column is 5 4 3 2. So which is the order of 3 rows and 4th column. So this is how we will construct a matrix with the help of number of rows and number of columns, writing the matrix in general form. Next question. If a matrix has 24 elements, what are the possible orders it can have? What if it has 13 elements? So if a matrix has certain number of elements, it means it is the product of number of rows into number of columns. So 24 means, just write the factors of 24. What are the factors of 24? We can have 1, 2, 3, 4, 6, 8, 12, 24. So therefore, the possible orders. So the possible orders it can have is, that means it can contain only 1 row and 24 columns. So that is, it is 1 into 24. Or it can have 24 rows and 1 column, that is 24 into 1. So, or it can have 2 into 12 or 12 into 2. Or it can have 3 into 8 or 8 into 3. Similarly, it can have 4 into 6, 6 into 4. So these are the possible orders it can have. That means here it can have 2 rows and 12 columns, or 12 rows and 2 columns, or 3 rows 8 columns, 8 row 3 columns, or 4 row 6 column, or 6 rows 4 column, or 4 rows 6 column, or 6 rows 4 columns. So however it may be the order of matrix, the total number of elements will be always equal to 24. Now, we have a sub question, what if it has a 13 element? Since the only factors of 13 is only 1 and 13, the possible orders for this matrix is either it can have only 1 row with 13 columns or 13 rows, 1 column. So therefore, the only possible orders of this matrix is 1 into 13 or 13 into 1. Next, we have types of matrices. So the very first one is a column matrix. What does a column matrix means? A column matrix means it has only 1 column and m number of rows. A matrix having only 1 column is called column matrix, and the order of column matrix is always represented m into 1. So that is, it can have m number of rows but should have only 1 column. For example, we can take x is equal to x, y, z. See here you have 3 rows and 1 column. So Y is equal to A, B, C, D. So here you have 4 rows and only 1 column. So therefore in general, any matrix A can have A11, A21 and last one will be AM1. So that is, it can contain m number of rows but only single column. Next one, row matrix. As the name itself says, it contains only one row. So the previous example which we have taken of order 1 cross 13. So, or 13 cross 1. So 1 cross 13 means it has only one row. So it will have 13 columns, A, B, C, D, like this. A matrix can have only one row but any number of columns. That is why the order of the matrix or a row matrix is given by 1 cross n. That is, it can have n number of columns but only one single row. Next one, square matrix. A square matrix is a matrix where number of rows is always equal to number of columns. That is, a matrix in which the number of rows is equal to the number of columns is called square matrix. Hence, the order of matrix is m cross m, or simply we just say it is as m, because the number of rows and number of columns is same. For example, I can take matrix A is equal to 1, 2, minus 1, 0. So clearly this is a matrix of order 2 cross 2. And a matrix A is equal to A. 1 cross 1 is a square matrix. Similarly, the matrix of order 3 cross 3, 4 cross 4, 5 cross 5 are all example for square matrices, because the number of rows will be always equal to number of columns. Note here, in any square matrix, the elements A11, A22, A33 constitute the principal diagonal. So you can clearly see here I have taken an example of order 3 cross 3 matrix. So 3 rows and 3 columns. So the matrix or the element inside the matrix. So this is A11, this is A22, this is A33. So these elements are called as principal diagonal elements, and the other remaining elements are called as non-diagonal elements. So here for this matrix, 3, 5, 1 by 2 are called as diagonal elements or principal diagonal elements. So in any square matrix, so whenever the row number as well as column number are equal, the element which have both the row and column number same, those elements are called as principal diagonal elements. Next one, we have diagonal matrix. What is this diagonal matrix? It's a square matrix in which its non-diagonal elements are 0. So previously I have said in a square matrix, the elements A11, A22, A33 are called as principal diagonal, and the rest of the elements are called as non-diagonal elements. So here minus 1, 0, minus 7, 3 by 2, 4, 3 are called as non-diagonal elements. So in the similar way, a diagonal matrix means it's a square matrix where with non-diagonal or elements are 0. For example, we can take a square matrix A is equal to 1, 0, 0, 1. So this is the principal diagonal elements. Or we can take matrix B is equal to root 3, 0, 0, 0, 5, 0, 0, 0, 1 by 2. So clearly see, except the principal diagonal elements, all other elements are 0. Hence, these type of matrices are called as diagonal matrix. Next one, we have a scalar matrix. What is a scalar matrix? It's a diagonal matrix in which all diagonal elements are equal. What is diagonal matrix? A diagonal matrix is a matrix in which all non-diagonal elements are 0. So therefore, a scalar matrix is a matrix which is a diagonal matrix and all its principal diagonal elements are equal. For example, I can take x is equal to 5, 0, 0, 5. See here, the diagonal elements are equal and it's a diagonal matrix also. Or we can give one more definition for a scalar matrix, that is, it's a square matrix where its diagonal elements are same and non-diagonal elements are 0. I can take an example of a 3 cross 3 matrix. This is matrix A is equal to root 5, 0, 0, 0, root 5, 0, 0, 0, root 5. See here, the principal diagonal elements are same and non-diagonal elements are 0. So this is an example for a scalar matrix. Next we have an identity matrix. An identity matrix is a square matrix where the diagonal elements are equal to 1 and non-diagonal elements are 0. And it is always denoted by capital I. So therefore we write I is equal to 1, 0, 0, 1. This is an identity matrix of order 2 cross 2. I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is an identity matrix of order 3 cross 3. So the principal diagonals are equal to 1 and the non-diagonal elements are 0. So we can also say an identity matrix is a scalar matrix whose principal diagonal are equal to 1. Next one, a null matrix. A null matrix is a matrix in which all its elements are 0. So it may be of any order. Okay. So I can take A is equal to 0, 0. This is an example of matrix 0, 0, 0, 0, 0, 0. So this is one more example of a null matrix. Or we can take matrix B is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. So therefore, a matrix in which all its elements are equal to 0 are called as null matrix and it is denoted by capital O. Now let's look at the problems here. Find the value of x and y given matrix A is equal to 6, x, 0, y is a diagonal matrix. So what is the speciality of diagonal matrix? So the diagonal elements belongs to some real numbers and the non-diagonal elements will be equal to 0. So this is a 2 cross 2 matrix and here the diagonal elements should have some real values. So therefore y may be any real number. It can take any real value and x is equal to 0 because it is equal to the non-diagonal elements. We know that in a diagonal matrix all non-diagonal elements are 0. Next one, find the values of x, y, z given matrix B is equal to x plus 5, 0, y minus 2, 0, 6, 0, 0, 0, z plus 3 is a scalar matrix. What is a scalar matrix? A scalar matrix is a matrix where its diagonal elements are same, non-diagonal elements are 0. So if the diagonal elements are same, these three must have the same values. That is why x plus y should be equal to 6. This implies x is equal to 1. Similarly, z plus 3 is equal to 6. This implies z is equal to 3. So this is the value of x as well as z. Next, we need to find out the value of y. Since in a scalar matrix, non-diagonal elements are 0, y minus 2 should be equal to 0. This implies y is equal to 2. So this is the value of x, y and z. So this is all about how we can write the order of a matrix and how we can find out the element in any row as well as any column. We have also studied the types of matrices and how to find out an unknown value inside the matrix when it is diagonal as well as scalar. So we will meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.